Good morning. So first video is about causes of flooding. So hopefully you've already done as I've asked and you've watched the video on slide 2, which gives you some introductory ideas and you've already started mind mapping. So I'm going to give you some extra ideas to put on your mind map in relation to the picture on slide 3. And I'm also going to explain some of them and why they make such a difference in causing floods. So you've got some obvious ones, first of all. They term it on the diagram event rainfall. What they mean by that is they mean a storm event or a rainfall event. So nice and easy one to start us off. Obviously, if you've got a small storm with a little bit of rain versus a much bigger storm with a lot of rain, a lot of heavy rain, intense rain for a long period of time, obviously you're going to get a larger flood event or more of a chance of a flood if you've got a large rainfall event. So that's what that one means. You may have also seen there's one called, I think they use the posh word antecedent rainfall, but you don't need to know the posh word. But the other type of rainfall is just kind of rainfall over a period of time. So I'll put the posh word down. Antecedent rainfall. So what that means, if you've already had, say you've had 1 month already of rain, your ground is going to be so full up of water that any event rainfall that might have, so say you had a month of rain followed by a big storm, you're likely to have a more severe flood than if you'd only had like 1 day of rainfall. Then your soil and your ground might still be able to take in a lot of a storm's worth of rain. So dependent on the rainfall that's already happened over the last month or 2 months, depends on how likely it is that you're going to get a flood. So causes of flooding so far, event rainfall, so a big storm or a big rainfall event, and sort of general rainfall that's happened over a period of time, posh word, antecedent rainfall. So how much rain has already fallen on that ground. And it just means either if you've had a month worth of rain, your soil, the airspace in your soil is completely filled up with water already, meaning it's saturated and can't take any more. If you only had a tiny bit of rainfall, then any rain that does fall is going to soak into the ground quite nicely. So what else have we got? Let's stick on the theme of precipitation and talk about snow. So snow's not a problem. If you've got snow, in fact, it means we're less likely to have a flood. The problem is, if we have a lot of snow on the ground, or you've got snow up in your mountains, for example, and then suddenly, it's meant to be a flame, by the way, not like a little Pope's hat, but if suddenly it starts to heat up, obviously we know what's going to happen to this snow. It's going to melt, resulting in lots of water suddenly inundating the land. So snow melt is quite a common cause of flooding. So what I'm going to get you to do in a minute, and I'll kind of do this as we go to try and help you out, is I'd like you to look at all the different ideas that you've got on your mind map and code them as to whether they are physical causes of flooding, so natural causes of flooding, or whether they're human causes. Now, at the moment, event rainfall and storms, we can't do much about as people. So this one is entirely natural or a physical cause. Again, the amount of rainfall that's fallen over a last month, again, we don't have much to do with that. We can't change the weather, so that'll be an entirely natural one. Again, if you have a period of snow and then the temperature warms up and we get flooding, there's nothing we can do about that. Again, that is an entirely natural cause of flooding. So what should we do next? Let's talk about vegetation, because that's an interesting one. And on your diagram, they call it catchment vegetation. I'll put veg, you know what I mean. And what that means is the type of vegetation that is in your catchment will determine how likely it is to flood. So say, for example, one part of your catchment has got some forested areas. Again, I'd encourage you to do some diagrams as well, because it does help when you come to revise. And say another part of your catchment has just got a little bit of grass, or maybe it's got some bare soil as well, no vegetation there at all. Vegetation is so important, and we're going to mention this again when we talk about rainforests in year 2. I don't know if you've seen on the news, I expect you have, or you've probably studied it at Key Stage 3. When we cut down trees in a rainforest type environment, it does all sorts of really bad things. But one of the things it does is it takes away the time that it takes rainfall to get to the ground. And what that means is it can cause flooding, it can take away the soil, it can completely erode the soil, so it's a bare rock. It can completely devastate an area. So we need vegetation, in particular we need trees, because they sort of help maintain a nice environment, I guess. So if we have rain that is falling on a tree, what's it going to do when it hits the tree? It might get stuck on a leaf, it might stay there for 10 minutes or so. It might hit a leaf, drop down to another leaf, drop down to another leaf, drop down to another leaf, get to the bottom, and then fall onto the forest floor. In a rainforest, they've actually measured this for some reason, and it can take up to 10 minutes for a raindrop from the top of the tree's canopy to actually reach the ground. And we call that interception. So the trees intercept the rainfall and slow it down. So it's almost like a little zigzagging maze to actually reach the forest floor. Now, if we had rainfall falling on our grass over here, it might hit that blade of grass and then run down it, for example, or maybe hit another blade of grass and go from one to another. But again, that might take seconds to get to the ground. If it's falling on bare soil, it's obviously just going to hit the soil. So depending on your type of vegetation, depends how quickly your rainfall is going to eventually get into a river and make it flood. So if you've got lots of forested areas, your catchment's less likely to flood because the water's slowly going to trickle into the stream. If you've got sort of short vegetation like cropland, for example, or bare soil, your water's very, very quickly going to get into your stream, and it means it's more likely to flood. So vegetation's really quite important. This is an interesting one when it comes to natural or human, isn't it? So naturally, we would have forested areas and grass areas. So you could possibly say this is natural. But as people, obviously, as I said before, sadly, we come in and we bulldoze forests, we deforest. So we actually can affect this too. So I would say it's natural until humans get involved. And if we cut down the forests or change the vegetation there by planting crops, then perhaps it can be our fault too. So it's a bit of both, that one. So let's go on to the actual human ones. So they term one of them land use, and they've got pictures of all sorts of things. They've got pictures of, like, I don't know how to draw this really, but that's meant to be farmland or crops or something. And then they draw like a little, here we go, my amazing art skills again. There's my little cow. Here we go, spots on it. So depending how we use the land can depend on what we do in terms of making it more or less likely to flood. So we're definitely talking about people being involved in this one. So I'm going to put a H for human there. So if we turn the land into cropland, a bit like we said down here, we can alter how fast the rainwater is going to get into the river system. Things like cattle are actually quite bad for things like flooding because they're very big, heavy animals, and what they do is they compact the land and they kind of compress all the soil. And what that does is it means that all the space that would usually be in the soil to take up water, it just isn't there because the hooves of the cows have kind of compressed it. So that can make it more likely to flood, and the water can't go into the soil, it just flows directly over the top and straight into a stream. So cattle and farming can actually make it more likely to flood too. But on an even bigger scale, of course, and I'll do like a little arrow up here. And you all know this word from the human studies that we did, urbanisation. So if we go and, again, in terms of how we use the land, build cities and things like that, and more importantly, put roads in those cities. What we do, again, is one, we cut down the forest. We know what the forests do. They slow down the rainfall. Two, rather than just compacting the land like cows do, we've actually taken away the soil completely and we've replaced it with tarmac and pavements and stuff like that. All of which doesn't allow any water to flow through. Again, a nice key term for you, it is impermeable. Meaning that water cannot get into those surfaces. So if rainfall were to fall on our tarmac road, it's just going to flow into probably a sewer or a drain somewhere. There's none of this happening. There's no delaying of that water reaching the ground. They've actually sped it up to get into our river systems, which means it's going to really, really increase the likelihood of us flooding. In fact, sewers and drains are another big problem with the cities. We put these rivers and these drainage systems in and these sewer systems in to stop flooding. But actually what we do is speed the water up going into those sewers and those drains. Those sewers then lead into rivers and actually cause flooding somewhere else. So land use in terms of urbanisation and cities really, really can increase the risk of flooding elsewhere, but maybe just not in the city itself. Which again, course, is human. There are others. So what I would like everybody to do as a minimum is to get some human ideas down and some natural ideas down. If you're pathway 1 and 2, can you please have a look at slide 3 and have a look at some of the other factors on there, such as new houses built, that it mentions farmland, which you kind of covered already, impermeable rock. If you need to do a bit of research as to how they actually impact flooding, then please do. But most of them I've kind of briefly mentioned anyway. So absolute minimum, get these down, pathway 3 and 4. Pathway 1 and 2, have a look at some of the other ones on slide 3 as well. One more video to go on hydrographs. Hopefully this is sort of helping in terms of there being some sort of taughtness of the content. I'm hoping that we might get a Google Meet session set up at some point, maybe next week, just to have a bit of a catch up. But I hope these videos are helping anyway.